And good morning, everybody. My name's Matt Williams. I work on the Juju core team. But today I'm going to be showing you a side project I've been working on, which allows us to create problems with networks between units. So if you're writing a distributed application, you need to be able to cope with the network going wrong. So it's useful to be able to have a tool that lets you play around with causing all sorts of network problems. So I've written a tool called Juju, which is a shameless name ripoff from Jepson, which is the Carl Kingsbury's blog posts all about networks and databases and how you can cause problems with them. And so what I'm going to be showing you today is to begin with just a few of the commands that are available. I'm just going to show you two units pinging each other, and then I'm going to cause problems on the network that you'll see in the output of the ping. And then I'm going to run an application using a mongodb replica set. I'm going to cause a partition across the replica set, and I'm going to show you some things going wrong. And if you've got time, I'm then going to show you how you can fix some of those problems. So there's going to be a couple of points when we run that demo where we're going to be waiting for a minute for things to happen. So if you have any questions, feel free to type them into IRC as we go. Okay, so we're going to start off with the ping demo. Okay, so in the top left window here, we've got a unit which is Ubuntu 0, and in the top right here we have Ubuntu 1, or we will do. Okay, and I'm going to set those two units pinging each other now. And they're both running on EC2, so you can see that they ping each other quite quickly. And Juju is the command that I've got, and there's all sorts of things that are available here. So to begin with, we're going to slow a unit down. So we're going to slow down Ubuntu 0. And after I hit enter, you should see the ping time change from 0 milliseconds up to 50 milliseconds. There we go. So this is just slowed down the network on Ubuntu 0. So we can do the same to Ubuntu 1 and we'll see the time jump to 100 milliseconds. There we go. So we don't really want to leave it like that. So we're going to fix Ubuntu 0, if I can spell it. You can see that it's also printing out the command that it's running over SSH. We're going to slow down 1. You see it's fallen to 50 milliseconds, then it will drop to 0. So that's slowing down the connection. We can also just cause a partition. And we're going to do this between Ubuntu 0 and Ubuntu 1. I think I just called it part because that's much easier for me to spell. So we'll see the ping stop at the top because I've caused a partition. There we go. And then I'm going to heal. And they should both be happy again. There we go. Okay, so now we're going to move on to the Mongo demo. I'll just quickly check if I've got any questions in the chat. Mute for a moment, you'll see my face. Okay, so the Mongo demo, I've got a replica set with 5 units. To begin with, the MongoDB 0 instance is going to be the primary, so that I'm going to be doing all reads and writes from that node. I've also got it set as the highest priority as well. So as long as this replica set stays intact, 0 will always try to become the primary. Well, what I'm going to do is cause a partition between 0 and 1 and 2, 3, 4 and 5. So at that point 0 will no longer become the primary, and they'll then enter leader election, in which case some of the unit will become the primary. I've highlighted 4 here, but realistically it could be 2, 3, 4 or 5, I don't know. But what will happen then is it will heal and 0 will become the primary again. And that is going to cause some problems. So we'll go back to the terminal again. I'm going to stop pinging for now. Okay. And so what I'm going to be doing, so this is the code I'm going to be running to show some problems that we can cause. So what I've got is basically a document in Mongo which contains a list of numbers. And what I'm going to do, if my memory serves me right, is I'm going to be updating that list of numbers each time I do an insert. So the idea is I will update that with a new item in the list each time, and I will know whether that write has been successful or not, obviously from the call I make to Mongo. And I'll know at the end how many have been successful and how many have failed. And I'll then ask Mongo one last time if it can tell me how many items are in that list. So in theory, those two numbers should match up. But what we might see is that those numbers don't match up. And that means that either we've written some data that Mongo told us it wrote, but it didn't, or Mongo will tell us that it didn't write some data, but it did. So I'm not picking on Mongo in particular, but this is just a fun one to do. And so I'm going to be running this partition script. And you can see this. So this is just going to be splitting up the group into the two groups, the MongoDB 0 and 1, and then 2, 3, 4, and 5. So I've just got this as a script that will just split us into that. And I'm sort of cheating because I can't really be bothered to type out the command. So that's what I'm going to be running. So I'm going to get ready to partition it, and then I'm going to set us running. And it will print out as we do each write. So we've done 100 writes. I'm now going to set us partitioning. So it's just going through each of the connections, and it's switching them off. And when it's finished, we'll have the partition as I had in the diagram. And it will then wait for 60 seconds, and then it will heal again. And what we'll see in the top is we'll see a connection get dropped as our primary node gets demoted, and then we'll see writing start again when another node gets promoted. And then when the primary switches back to MongoDB 0, we'll see that switch again in the top there. So you can see at the bottom there we've partitioned. So now in the background leadership election will start to happen. MongoDB 0 will get demoted, and you can see we failed to do a write there, and that's because we tried to do a write and the unit had been demoted. So in a moment we'll recover again. And we can see writing has started again. And now we're starting to heal again. So now we've failed to write because the replica set is now healed. So whatever became primary is now being demoted, and 0 is going to get promoted again. And we're going to get our connection back to 0, and then we'll carry on writing. We'll just go up to 3,500. And while it's doing that, I'm just going to point out that the write mode we're using actually waits for fsync to run. So we're getting confirmation that the data has been written to disk when Mongo returns success to us. But we're not waiting for this majority mode, which we'll get onto in a second. Okay, so you can see at the top here that we did 3,498 successful writes, and we know about the 2 that failed, which were when the primary switched. So we expect 3,498 items to be in the list, but we only get 3,165, which means we've lost roughly 300 inserts. They've just disappeared. So it's worth reading Carl Kingsbury's blog posts to get a bit more information about why this is happening. But for our purposes, we're just going to switch on the majority write mode. And what this says is that as well as us requiring that items have been written to disk, we also require that the majority of nodes in the replica set have confirmed that they've written data before Mongo will tell us that a write has been successful. So what we're going to do is we're going to run our test again, but we're going to be using this majority write mode, and I'll show you the difference. So with this example, just going to turn majority to true, and I'm going to get ready to run, and we're going to cause a partition in the same way as before. And we're going to set all that going. And while this is running, I'm just going to show you this is the Jupson project. So this is on github.com/mattheww/Jupson. It's a Go program, so you can just go install it. I've not released binaries of it yet, but I could do if anyone's particularly interested. But in this is the top level, and you can see there's this examples directory here, and in here is Mongo, and this is all the code that I'm running tonight. It's all in here basically. There's also a test in here which does exactly the same test, but it does it on gridfs instead of just a normal collection. Okay, so we've got our failed write because we've partitioned. And in a moment we'll start writing again. And so remember, this is with majority mode switched on. So the idea is Mongo won't tell us that a write has been successful until it's got confirmation that the majority of nodes in the replica set have also written it. Okay, so now we've healed the partition, and the write has failed as we've switched back to the other primary. Okay, so we finished. So we did 3,498 successful writes, 2 failed. So we can see we've actually got 3,499 items in the list. So this is an acknowledged write that we've seen here. This is where MongoDB told us that a particular write failed, but in actual fact the write had succeeded. So this is one of the reasons why it's useful to run this sort of tool on your app, because for some applications this might be a problem. You might need to know exactly whether something has been written or not. But in other applications it might be acceptable for you to be told that a write has failed, but it have actually succeeded. But you might not be fully aware of those failure modes unless you've tried it out. So the reason I wrote this tool was that it provides a useful way to experiment with these sorts of failures. So I've showed you partitioning and slowing down the network. You can also make networks flaky, where they'll drop packets across a normal distribution, and there's all sorts of options you can give it there. And the idea of that is that you can like in Carl Kingsbury's blog post, he causes problem with the 3-phase commit in Postgres and things like that. So all of these tools are available to try other experiments, but Mongo is the main one I've been experimenting on at the moment. So that was the end of the demo. I'm going to leave up a page that's got the links to the project. So I can recommend reading the Jepsen blogs if you've not read them already. And if you use Juju and you fancy playing around with this sort of stuff, then that's the link where you can get Jepsen from to give it a go. So that's about it. Thanks very much for listening.